Hello, my name is Sara Legg, and I would love to become a Brooke Owens Fellow. I believe that one of the most prominent qualities that Brooke exemplified was passion as well as ambition. From my research, Brooke seemed to take advantage of any opportunity in which she would be able to learn something new. She worked at NASA Johnson, the X Prize, the FAA, as well as for the White House Office of Management and Budget. While each of those jobs might have required her to do something different, the central focus of advancing space exploration was always there. I believe that I exhibit similar qualities to Brooke by taking chances and trying new things. Last year, I was a project manager for the NASA Micro-G Next Challenge for the Illinois Space Society here at the University of Illinois. I did not start this project, but I took a leap and led a team to compete in this challenge without having any previous experience in leading a team or in designing and manufacturing a tool. I pursued this opportunity at first to improve my leadership abilities, but by the end of the project, I realized that this project had provided me more lifelong skills than I can ever imagine. The NASA Micro-G Next project focused on designing, manufacturing, and testing one of three tools: an anchoring device, a subsurface sampler, or a surface sampler. This device is intended for use on unknown celestial bodies such as asteroids. My team decided to pursue an anchoring device. We started with the requirements provided and began designing the initial tool we would submit for the proposal. After we submitted the proposal, we iterated on the design. When we heard we were accepted into the competition, the team got to work on finalizing the design and started to manufacture the tool. The team worked closely with the machine shop at our university to get the parts machined. The following images are some of the components that make up ALMA.
Don't know who I'm working for. I've made up my mind.
The anchoring device is called ALMA, which stands for the Adaptable Low-Cost Modular Anchor. This is ALMA in its final form. The final design was of an anchor that contained a reusable ratchet and had adaptable handles, as can be shown in the pictures. After the tool was assembled, the team began conducting initial testing of the tool to ensure its functionality. The tool had to be able to withstand around 15 pounds of force, but our tool was able to withstand 40 to 50 pounds in plain sand and around 60 pounds of force in gravel and pebbles. Both conditions were tested to ensure the tool would operate in any environment. After the tool was tested, the test equipment data package was submitted to NASA and the final modifications were made on the tool. The team was then ready to travel down to Houston, which is the final testing location for ALMA. When the team arrived in Houston, we were able to present our test readiness review in front of various NASA tool engineers, safety engineers, and the team of divers that would be using our tool. ALMA passed all safety checks and was ready to be tested in the neutral buoyancy lab. The next day, the team was able to test ALMA in the neutral buoyancy lab, and the results we obtained were better than we expected. The tool was able to hold more than the spring scale could read, and in the sand and regolith environment, the tool was so well anchored that the divers struggled to remove the tool from the testing bed.
Feel like anything can happen, laughing. You take me right back when we were kids. Never thought I'd feel like this. Like when I close my eyes and don't even care if anyone sees me dancing. Like I can.
With testing, we noticed changes that we could make for the future, but overall the tool was extremely successful. The divers told us it was the tool of the day, and they, along with other teams, praised the overall design of the tool. While this project was not a competition, we hope that NASA is able to use aspects of our design for future tools. This was my first experience being a project manager, and I learned so much. I learned how to delegate and how to incentivize my team members to work on their sections. I had to learn how to deal with conflicts and how to stick with the schedule. I also learned a lot about the engineering process. With this project, I got to see an idea turned into a CAD model, which turned into a machine tool that underwent successful testing. I improved my CAD skills and learned how to write test procedures and how to conduct a test. I improved my technical writing and presenting skills by writing a proposal, a test equipment data package, a test readiness review presentation, and a final report. Finally, the NASA Micro-G Next project taught me how to think on my feet and how to be aware of the next steps in a project. All the skills have made me a better engineer and have made me more aware of how a product cycle works. I've been able to apply these skills to other projects and in my internships these past couple summers. Overall, this project has made me realize that if I'm passionate enough and I have the drive to make something happen, I totally can.